which is interesting because internet identity is actually a core part of the internet computer ecosystem. And I believe it lights the way towards a sort of better future for identity on the internet. So a little bit about me. I've been building things for a very long time. I switched to work full-time on blockchain in 2013. 2014, I spent researching, repurposing Byzantine fault-tolerant consensus for the blockchain setting. I was the first person to do it, and trying to design sort of infinitely scalable blockchains. 2015, I switched my focus to trying to build a world computer, and the word Dfinity started being used. Dfinity Foundation was created here in Switzerland in October 2016, and eventually the Internet Computer launched a couple of years ago. I work for the Dfinity Foundation, and it's actually one of the larger Swiss tech startups, if you can call it that. We've got two main research centers, one here in Zurich, where we employ about 140 people, down on Genferstrasse, and another in San Francisco. Interesting factoids, I think we've got probably the world's largest team of sort of well-known, well-cited cryptographers. Dfinity is also led by influential digital identity researchers, and they've worked in areas like verifiable credential sharing, privacy enhancing authentication, zero knowledge proofs, that kind of thing. Our CTO has published various seminal works in the space. Jan Kameny, she's here somewhere. Can't quite see him, but oh yeah, there he is over there, guy in the hat. So we're very well placed, to work on identity, and it's also very core to what we do. I'm going to try and run through this pretty quickly and keep this high level, and then we'll have time for a Q&A at the end. But we all know the problems with identity. So in the US last year, $43 billion was lost to identity theft and fraud. More than 1 in 10 people were impacted, and it disproportionately affects economically disadvantaged people. So African Americans, like 26% of African Americans suffered from some form of identity theft or fraud, and 27% of Hispanics. So this is a really big problem with real human impact, and it needs to be solved. So what is the future of global digital identity? Is it sort of MasterCard Visa equals passport? I hope it's not. To understand why, you can just search the web for examples. This was one that caught my eye. This YouTuber asked his sort of followers to how many emojis they used in messages or something like that. All his followers started putting lots of emojis into their messages under his video, and Google's algorithms banned them, which of course meant that their Google logins stopped working. They were also locked out of their Gmail and many other sites if they'd use single sign-on. And I think that's emblematic of the kind of problems that can arise if digital identity depends on US corporations, or indeed corporations of any kind at all. In the future, your digital identity will give you access to your banking, to your social media, and just about medical records, just about anything you can imagine. And it'd be absolutely terrible if your access to almost like life itself, your digital life, could be denied on the whim of a corporation. So, we would certainly advocate that Europe and the world more generally needs, open and tamper-proof forms of identity. So, better online identity, internet identity. What's it all about? There are sort of 3 magical ingredients which come together. The first is TPMs, trusted platform modules, these chips inside modern devices like phones and laptops, which can securely store a private key inside in a manner that they can't be extracted. So, these are typically linked to biometric authentication systems like fingerprint, Face ID, and so on, and allow a session or some other message to be passed inside the chip where it can get signed. Nearly all modern devices have these now. There's a protocol called WebAuthn, which links web browsers to the sort of TPM hardware on your device, and this makes it possible to integrate web experiences with that hardware. And then finally, there's the Internet Computer itself, which provides a tamper-proof computing platform that's a public platform too. So this is how it works. OpenChat is a sort of messaging service. It runs 100% on the Internet Computer. It's quite unique actually because not only does it run 100% on the Internet Computer, but it doesn't have a human controller, it's autonomous. I won't go off on a tangent, but essentially this means it's controlled by a DAO. There's no backdoor or anything like that. There's a community of many thousands of people who hold governance tokens in the DAO, and the service is updated by proposing updates, software updates, smart contract software updates to the DAO. And if those proposals are adopted, the DAO pushes them. So it's updated in a completely secure and transparent way that, of course, is also open and permissionless. Anyways, you should go and check out what's possible if you get a chance. But let's say you just browse to this OpenChat service. It's delivered via the browser. It's at oc.app. This is what you'll see. And there's a button that says Launch App. Launch App actually is going to try and open the app within the browser. It'll then forward you, if your session has expired, it'll forward you to the current internet identity URL. Here it says, choose your internet identity to connect to OpenChat. Someone has previously used this particular internet identity, so they just click on it. And it says, authorize your session using your device passkey. In this case, they're using Face ID, but it could be PIN code, it could be fingerprint, it could even be an external YubiKey or something like that. And bingo, they're in, right? They've got a instantly secure interaction is enabled. So it's very easy to use and works pretty much universally. So you might be wondering, what's the Internet Computer? You've probably heard about TPMs and you've probably heard about WebAuthn. So the Internet Computer is best understood as a kind of tamper-proof autonomous cloud. It's actually a blockchain, but its properties are so different to a normal blockchain. If you start thinking about it as a blockchain, you'll go down the wrong path. The primary purpose of it is to support this, to run this new kind of software. So tamper-proof software began with Ethereum, which introduced smart contracts in 2015. And smart contracts are unique because they do these amazing things. They're tamper-proof. They always run the expected code against the expected data. You can't infect them with ransomware or something. They're unstoppable. They're autonomous, which means they can exist without a human controller. They support token. They can process tokens, so you can process value as data. They're composable. They're borderless. And the Internet Computer evolves this paradigm and essentially delivers a new kind of smart contracts called canister smart contracts that enable the tamper-proof cloud. They're multi-chain, they're scalable, they're efficient, they're low cost, they're very fast, and they process the web, so you can actually create web experiences with smart contracts. You might be wondering about the efficient word. The intention is that the Internet Computer will be more efficient, will support the creation of systems that are more efficient than those that run on traditional IT. This is real technology, and you can find out more about it online. The main mission of the Internet Computer is to advance the internet from being a network, a public network that connects everybody and everything, to also being a tamper-proof public cloud that the world builds on. So, generally speaking, we describe our purpose as enabling the world to build on the internet itself. So the internet is not just a network, but it's also the platform on which we build, without need for traditional technology like Amazon Web Services and databases and web servers and things like that. You might be wondering how it works. Internet Computer Protocol is a crypto protocol that combines something called node machines, a special kind of device built to public standards that are run by independent node providers. So anyone who's interested can go to the online docs and become a node provider if they wish. These machines cost about $20,000 each, and you typically need to install them in data centers in areas where the internet computer network needs more decentralization. And these node machine devices are combined by the protocol to create subnet blockchains. Again, could be careful of that word blockchain. These things are very, very efficient and powerful. And each subnet blockchain, of course, increases the capacity of the overall internet computer. They're genuine subnets in the sense that they'll get combined. Each subnet, of course, replicates and runs these things called canister smart contracts, and they're combined together to form a sort of planet-scale virtual supercomputer. And our mission at Dfinity is to drive a sort of blockchain singularity where, over time, eventually, the majority of the world's systems and services are in fact built on the public internet, on the internet computer itself, rather than on traditional platforms. So this thing, can scale as needed. One of the really cool things for those of you that have interests in cryptography is that it's powered by this thing, what we call chain key cryptography. And what's so cool about this is that anybody can interact with the internet computer, no matter how big it gets, and just check that the messages or results that it's receiving back from the internet computer have been signed by a single master chain key. It's just a 48-byte key. So all you need to know, if you know this 48-byte master key, you can validate any interaction with the internet computer. And if you think about that, the number of, I think currently the internet computer is processing sort of 250,000 Ethereum equivalent transactions a second, right? Go figure, right? This is a pretty cool system. And you can build absolutely anything. I mean, there's so many examples. This is actually a kind of like full order book exchange run on the internet computer. And if you look at it, it's probably too small for you guys to see, but if you look in the URL, the address bar of the browser, you can see some strange long number. That's because this exchange is in alpha. They're not using a friendly domain name yet, and the address you're looking at is the address of a smart contract on the internet computer. And that's smart contracts are producing the user experience as well as all of the other kind of logic that goes into an order book exchange. In this architecture, and we just mentioned that people interact with these smart contracts over the web. There's web browser cryptography that's transparently verifying interactions. So here you've got the network's master chain key, which is signing the responses from the network, and obviously the requests to the network are being signed using the traditional keys of end users, which of course lie inside the TPMs. Internet identity, is easy to use, and that's very important. Like, people won't adopt identity systems that aren't easy to use. I would argue that identity has to be easier to use than traditional Web 2 forms of identity, like usernames and passwords. It has to be interoperable. So currently, internet identity is only used within the internet computer domain, but it's actually interoperable. You can create a Web 2 site, on traditional infrastructure if you wanted, that could use this same system. It's open source naturally, provides self-sovereign identity features, which we'll come to. It has to be highly secure and prevent tracking. This is another big one. On the internet computer, you might have one internet identity, but your use of different services cannot be tracked. And this is absolutely essential. Seeing some good use. We're still in the early days, but there's about 2.2 million identities created, 50,000 monthly authentications, and 100 plus online services using the system. The next phase, in terms of the technical development of internet identity, is property-based identity, right? Where you can use your internet identity to prove properties about yourself. And that's an interesting thing, because right now, internet identity is specifically designed to anonymize you, right? To maintain your privacy, to prevent you being tracked across your usage of different services and things like that. But in the next phase, we'll allow people to optionally prove properties about themselves. So here's the basic story. You know, yeah, there's a nightclub and there's some big burly bouncer, and some young girl approaches to get into the nightclub, and he says, prove you're 18, darling, and she says sure, and she hands over her driving license. Now, what's the problem with that? Well, actually, there's a big problem. She's just given her name to a stranger and her home address. And all she wants to do is prove she's 18 so she can get into the nightclub, but she's been forced to hand this guy her name and address, right? That's actually a big problem, and it's prototypical of problems that happen in the identity space generally. We're always having to scan our passports, driving license, utility bills, and things like that, and upload them when we apply to participate in new services. And the result is that our PII is littered all over the world on people's insecure hard drives, and inevitably it gets sort of harvested by hackers and sold on 4chan and things like that. That's most of us will find most of us have a large part of our PII on the internet somewhere. It's just the reality of it. So the solution, courtesy of zero knowledge proofs and property-based identity, is that this young lady would walk up to the nightclub bouncer, and he would just see, through NFC or something like that, he'd just see the young lady's picture with a tick saying over 18. That's it. He doesn't need to know anything else. And the underlying attestations and cryptographic material involved, of course, will be created by attestation agencies and things like that. But this really is the future, and that's where we need to be. Like identity, the problems with identity will never be solved so long as everybody is taking scans of the utility bills and passports and things like that, and sort of emailing them or uploading them to this or that rando service, and creating copies all over the internet. So I don't know if we missed anything. Obviously Jan is going to be here longer than me, and you can tell us about problems that you're looking to solve. We like collaborating with people. We're hoping to find people with use cases for this technology. You can try it yourself if you're interested in creating an internet identity. Just take this QR code. We've got a booth there, I believe. You can come and meet us. More people are around. I think I tried to go quickly so we had some time for a Q&A. I think I'm good, right? I've got like 15 minutes or something. All right, good. And